Hello everyone, welcome to our YouTube channel Metallurgical Engineering. So in this video we are going to see the significance of the grain size in metals, how grain size affects the various mechanical properties and other properties as well. So first let's understand what is grain size. So grain size is refers to the average diameter of the individual crystal or grain within the polycrystalline material. So let's suppose here you have a polycrystalline material here and which is having different grains here. So the grain size is the average diameter of these individual grains within this polycrystalline material, so that we called as grain size. All right, and another thing which we should know before going into the main this topic of this video, how you can control the grain size, how you can change the grain size. You can change the grain size using various metallurgical process like casting, like you have some technique, I mean this severe plastic deformation, like you have forging, you can also have a rolling, extrusion and this kind of thing. And another important thing, you can change this grain size this using heat treatment. So these things you can use to control the grain size. These metallurgical processes you can use. Now let's come to the main topic of this video. So how this grain size affect this strength and hardness. So basically the grain here is strength and hardness, which is we call, I mean you have remembered the this a famous equation, Hall-Page relation, which tells about that yield strength is inversely proportional to the square root of grain size. So this strength and hardness is inversely proportional to the grain size. So if you have a smaller grain size, then the strength and hardness will be higher. Now let's come to the ductility. So this ductility, percentage of elongation, is directly proportional to the grain size. So here I am talking D as a grain size. It directly was to the grain size. So if you have a larger grain size, then the ductility will be higher. But this is only this thing will only happen for the room temperature. But if you are talking about high temperature application, so this thing will be reverse, where percentage of elongation will be inversely proportional to the grain size. All right, and then let's come to the toughness, which is again another important factor that already depend on the ductility here. So this this toughness is, there are two types of toughness. The normal toughness, which we determine from the engineering stress strain diagram. Another one, you have a fracture toughness here, right? So basically this, if you are talking about this fracture toughness, so this fracture toughness is inversely proportional to the grain size. So if you have a smaller grain, which will enhance the toughness by making crack propagation more difficult. All right, this is inversely proportional to the grain size. Now let's come to the fatigue resistance. So the fatigue resistance is again inversely proportional to the grain size. So if you have a smaller grain size, that will improve the fatigue life of the material. It means that it will improve the fatigue resistance of the material. Now let's come to the creep resistance, where we're talking about in higher temperature application. So this creep resistance is directly proportional to the grain size. So if you have a larger grain size, that will improve the creep life of the material. That will also improve the creep resistance. Now let's come to the corrosion resistance. Again, corrosion resistance is inversely proportional to the grain size. So if you have a smaller, it is directly proportional to the grain size. So if you have a larger grain size, that will mean you have a higher corrosion resistance. So just if you, if you wanted to understand, if you have a higher grain size, a larger grain size, it means you have a less grain boundaries. And if you have a less grain boundaries, so it will be less corrosion sites and the corrosion resistance will be higher. So corrosion resistance is directly proportional to the D. Now let's come to the formability. So if you are talking about formability, so at room temperature, the smaller grain might make metals harder to form due to increased strength. However, at higher temperature, finer grain can improve the formability by promoting recrystallization. So in the terms, this formability is directly related to the ductility, how we tell about, right? So if at room temperature, if you have a smaller grain, so it means you have higher strength, so it will be more difficult to to do this formability, right? So it means the formability is the directly proportional to the D for room temperature. Even at higher temperature, it can be inversely proportional to the grain size. Now let's come to the recrystallization temperature, the another important, the last one I mean here. So grain size influences the recrystallization temperature. Like if you have a smaller grain size, that can recrystallize at lower temperature, which is again useful in the annealing process. So smaller grain size means lower recrystallization temperature. So this recrystallization temperature is uh, directly proportional to the grain size. So now let's revise this thing. So recrystallization temperature is directly proportional to the grain size. If you have a higher grain size, your recrystallization temperature will be higher. Formability, again it depends on I mean at what temperature you are going to do the formability. So at room temperature it is directly proportional, at high temperature it is inversely proportional. For corrosion resistance is directly proportional to the grain size. Creep resistance is directly proportional to the grain size. Fatigue resistance is inversely proportional to the grain size. Toughness is inversely proportional to the grain size. Ductility is directly proportional to the grain size at room temperature and inversely proportional to the grain size at high temperature. Strength and hardness is inversely proportional to the grain size from this Hall page relationship. So this is the video. If you have any questions, you can write down into the comment section. Yeah, thank you so much.